Yes.
Can we go over the difference of quotients for rational?
Yes. So let's look at the function. We did one last time, and I'm sure you're going to ask something like 1 over 2x, right? Or 1 over 5x, or 1 over 3x.
7 over x.
Very good. 7 over x is good. Okay. So the difference quotient, by definition, and this will be given to you, it's f of x plus h minus f of x divided by h. Again, you do not have to memorize this. Second step, I look at it and I say, well, I cannot do anything to these two. And I also have in the back of my mind that two things must happen. Number one, all terms without h from the top must go away, otherwise I have an error somewhere. And this little h eventually will go away. That's the second step. It's never the first step. It's always the second step. Okay, so then I have to determine this. Okay, but there is no big deal. I don't have to write it on the side. I don't have to simplify it. It's not quadratic. The quadratic will have, will require more work, but the rational does not. So how do I find f of x plus h?
Would it be 7 over x plus h?
That's what the function says. The function says 7 over blah. And the blah is x plus h. Very good. Minus 7 over x divided by h. Perfect. Good. What is my next step? The denominator is the same with h over 1, and you'll see in a moment why. We're just preparing this for the next step. Okay, so what do I do? Of course. I have a difference of two fractions. I have to find the least common denominator. Very good. And the least common denominator is? They have nothing in common. This is not factorable. This is not factorable. It must be the product of the two. It's like 1/2 minus 1/3. The denominator is 6. Good. So now I have to find the adjustments for the tops. I cannot just write 7 minus 7. That would be incorrect. So what do I have at the top for the first one? Good. And for the second one? Very good. Awesome. Good. Can anyone dictate now the top of this fraction? Yes? But be very careful. We are distributing -7 to these two terms. Good. Minus 7h. Very good. And now we are ready to simplify this by saying, okay, the terms without h at the top must go away, do they? Yes, they do. Because 7x minus 7x is 0. Now I have this fraction. How do I divide a fraction? By another one. Right, I copy the top. I put negative in front, x plus h, and I multiply it by? Very good. And what was the second thing that had to happen? It's happening right now. The h from the denominator must go away. H divided by h divided by h. Please write 1 so you are not tempted to write 0. So this is -7 divided by x times x plus h. And this is the final form. What does it mean? It's the rate of change of that function. For any x where, and I can't say it because we don't know, but I can say it to you where the function is differentiable, but we don't know that. Not in this class. Very good. Other questions, please? Is there anything else you worked on? Anything else you'd like to see? Anything else from the previous lecture?
I would like to see the piecewise function.
Very good. Very good. So let's choose a piecewise defined function. If you have one from my math lab, that's fine. If you want to choose one from the book, or we can invent one. Can anyone invent? Do you want one with 2 branches or 3 branches? I think 2 is good enough. Okay. So let's say if and if. What would you like the first branch to be? Would you like it to be quadratic? Would you like it to be rational?
Rational.
I have to say we haven't talked about it. We haven't graphed rationals yet. I forgot. This is for chapter 3. In chapter 3, we will graph rationals. So it can be radical, it can be absolute value, it can be quadratic, it can be linear. Just choose something for the first branch. Okay, I will. So let's say the square root of negative x plus 1 for x less than or equal to 0. And let's say 2x plus 4 for x greater than 0. Okay, so what type of function is the first one? This piece? Radical. And it can be graphed only on this interval. And we're going to write the interval in a moment. And this is what type of function? Linear. And it has to be graphed only on this interval. What do we have to find first when we're asked to graph a function? Obviously, it's a piecewise defined function. So what do I have to find first? The domain. So in order to find the domain, I will change this into an interval notation. I will change this into an interval notation for 2 reasons. So can anyone give us this in interval notation? Awesome, perfect. Now, can anyone give us this in interval notation? 0 to infinity and parentheses, very good. So now I look at this, and here's how I think. I have x between negative infinity and 0. I have 0. And then I have anywhere between 0 and infinity. What is the domain of this function? All your numbers. Do we all agree? We all agree? Okay. So now I can get my chart started, my table. In which I put all real numbers as discussed. Okay, what value I have to have in the chart, without which I can't really continue. Yes, 0 must be in the chart no matter what, in general, but it happens that this case is also 0. Now, what do I write immediately under 0? Yes, but a parenthesis, careful opening this way, and the bracket opening this way. So a bracket and a parenthesis. Is that clear? It's to the left, the bracket, and the parentheses to the right. You have to look carefully at what we're given. We cannot guess, or we cannot choose. It has to be exactly what we have in the domain. Very good. So now I know this is an overkill, but it's a wise overkill. Which function will I use for x values between negative infinity and 0? Which I know it's a silly question at this point. Which function will I use for 0 to infinity? Good. Exactly, the other one, because there are only 2 branches. Now you can say, you have them over there. Yeah, but it's easier to say, okay, I'm plugging in here than over there. Okay, so now let's choose some values to the left-hand side. If I use -1, then I have the square root of 2. So let's choose it. It's a good one, but I really don't want to plot the square root of 2. Indeed, -3 is good. Thank you. So let's plug in -3 and tell me what you get. Right, do we agree? The opposite of -3 is 3. 3 plus 1 is 4. The square root of 4 is? Very good. So that's all I need. Now let's plug in 0.
1.
Yes, do you all agree? Notice that I put the 1 right inside of the bracket. And both symbols are immediately under 0. Not to the left, not to the right of 0. Is that clear? Okay, on the other side now, I have to plug in 0. What do I get? 4. That's okay. And then let's plug in 1. What do I get? Indeed. This is really all I need. Now, if I go back to, and again, I don't have anything against it, but if I go back to, where is it? In 2.2, I believe, right? The piecewise defined functions. There is no need for all this. Really, there is no need for all this. This is a waste of time. It depends on the function. If the function is linear, I only need 2 points. I don't need all this. If the function is 4, which is linear, I don't need all this. Just a waste of time. Too much work. That's my opinion. Okay, so now we are ready to graph this function. From left to right in order. From left to right, which is the first ordered pair you will ask me to plot. Here it is, -3, 2, and this is the point. What will be the second ordered pair that you will ask me to plot? Or you will plot? Good. What type of point is this, 0, 1? Do you all agree? Why? Exactly, which means it must be equal. Right. So I'll put the 0. Now let me refresh your memory how to graph a... Oh, I'm sorry. Yeah. You're right. I'm sorry. I put it wrong spot. Thank you very much. My mistake. Sorry. Absolutely. Good, because it's 0, 1. So let me refresh your memory on how to graph a radical function. This is not a straight line. So this is the square root of -x plus 1. Good. Now, can anyone give us the next point?
0, 4.
Right. What type of point is 0, 4? Yes, this is an open point. Why? Because it's 0, 4 with a parenthesis. And the next point would be 1, 6, which is this point here. Of course, I'm just exaggerating this. It shouldn't be this big. Okay, and this is a straight line. And this is it.
Why is that one close?
Because of the equal symbol. Because of the equal symbol. And because of the bracket. Is that okay?
Yeah, I was just thinking because it's over on that side towards the infinity.
No, but it's this way. The bracket is this way, and the equal symbol is this way, not that way. There's no equal symbol this way. Is that okay?
Yeah.
Everyone? Okay, very good. So is this clear? Yes? So let's find the range of this function, please. Is this better about the piecewise defined function?
Yes.
Okay, perfect. I recommend the method if you like it. If not, use the other one.
The range would be
Yes?
1
Exactly. 1 to infinity. How do I determine that? From the lowest y value, which is 1, till the largest y value, which is infinity. Very good. Good questions. Anything else? Is there anything else before we look at 2.5? Anything else? Anything else that we worked on? Anything else we have questions on? Yes?
I have a
Yeah.
problem with a couple of things.
Yes.
This is part 1.
Okay. That's okay.
It's 5 over 9x plus 9
5 over 9x plus 9
equals
Yes?
9 over
I couldn't hear you. I'm sorry.
9 over x plus 1 minus 2 over 9.
Perfect. Very good. Okay. So obviously I see this is what is it? Right. It's a rational what? Perfect. I have a left-hand side. I have a right-hand side. Okay. So what would be my first step?
Please come.
Not yet. That is not my first. But you're ahead of me like always. That's good. That's not my first step.
Move all your stuff inside.
Move everything, and also at the same time,
Oh, your zeros.
yes, but at the same time, what? Yes, what?
The 9 on
Exactly. 9 over 9 and 5 over 9 and in parentheses. Very good. Minus 9 over x plus 1 plus 2 over 9. And if I forget the right-hand side, I mess up the entire problem. What is the right-hand side? Very good. Awesome. Now I have to state restrictions. Let's look at all these denominators and please tell me what to write. Very good. Do you all agree with x not equal -1? Everyone? Is that clear why? Okay, very good. Now, only now I am ready to write and find the least common denominator. Again, this is a habit. If you think it's good, acquire it. If you think it's not good, forget it. So I always draw the long fraction line equals and 0 because if I forget this, I mess up the whole thing. Instead of solving, I change it into an expression. Okay, very good. So then the least common denominator is all different factors we see here. We only see 2 different factors. One of them is 9 and the other one is x plus 1. Agreed? Yep. Okay, so now remember, it would be a terrible mistake to write 5 minus 9 plus 2. We have to find the adjustments for each top. If it's 1, it's 1. If it's something else, it's something else. So what is the adjustment for the top of the first one? Yes. You don't have to write it. I'm just making a point. What is the adjustment for the second one?
9.
Do you all agree with the second one being 9?
Yes.
Good. And the last one?
X plus 1.
I agree. Very good. You're doing very well. Okay, so now please dictate the numerator.
5.
Yes, indeed. We multiply 1 by 5. Now we have to be careful because I have -9 that needs to be multiplied by 9.
-81.
And now careful because I have +2 that needs to be distributed to these two terms.
Plus 2x plus 10.
Very good. So far, so good? Okay, what will be the next? Yes, please.
How do you get 9 for the adjustment for the second one?
Okay, here it is.
What I do is I take the denominator and I just cross out for each little. It's the normal, like cross out the same.
Because
things.
you're multiplying.
Yeah, just
Because you're multiplying, but remember you have to multiply both sides, and if you don't move everything to one side, it's a little bit more complicated. So careful on that. So when I have 1/2 minus 1/3, what will be the least common denominator? Indeed. 2 was multiplied by
3.
3 was multiplied by.
Okay.
So that's how we get 3 minus 2. Of course, this is much easier because it doesn't have x in it. So now we come back to our problem. 9 times x plus 1 was multiplied by?
1.
Yes. X plus 1 was multiplied by?
9. Okay, yeah, I get it.
And then 9 was multiplied by? Good. Perfect. So now we have to continue, and I have to combine like terms. So we have 2x, and this is +7. -81 plus 7 will be negative, what is it, 74? Correct me if I'm wrong. 9x plus 1. At this point, I remind myself that this is now a proportion. And at this point, I will cross multiply. And this is 2x minus 74 equals 0. X equals 74 divided by 2. I move 74 and divide by 2. And I get 37. So what is the next step? I must check against the restrictions. I cannot just move on and say this is it. I wrote restrictions from the very beginning. This is the only one. I didn't get that, so this is the correct answer. So be careful with that method with multiplying because that's not, you have to be very careful with that. This, I think this is easier, yes.
How did you get 2x minus 74 equals 0?
We cross multiply.
So
Or where'd you get the 0? Is that because it's on this side?
It's the 0 on the right hand side. It's an equation. I have to have the left hand side and I have to have the right hand side. Please redo the problems we did in class. This is our first step. So this is 0, and I copied it as 0 over 1. Anything can be put over 1. 15 is 15 over 1. 0 is 0 over 1. And then we cross multiply. This times this equals this times this. Because this is a proportion. Is that better? Okay, very good. Other questions here? Is there anything else we want to work on, or can we start 2.5? Okay, then 2.5. Last section before the test, and the test is on Tuesday. And this is, today's the 2nd, so the 9th. Any questions? Any questions?
We just thought the test was on Thursday.
I have to review before we take the test.
Yeah.
Do you want to have the test now? I can give it to you now.
No. Don't do that.
I have never done that in 23 years of teaching to anyone.
And I appreciate you don't.
No, I will never do that. I will do it by request, though. Okay, so what is this concept of transformation? What does it mean? Well, it means this. If we know the basic functions, how they look, what is their graph, we can apply transformation to the basic functions to create other functions. Why would we want to create other functions?
Make it easier.
To fit a function through the data. So let's say, which I hope you're going to become data analysis for NASA. So let's say you go out there, or you select, or you get some data, and you are trying to fit the function through the data. Transformations will help. Okay? But before we talk about transformations, we have to make a list of about 7 different basic functions. Basic, I call them basic, others call them base functions, whatever you want. Functions. And we are going to look at a few of them. Polynomial. We're going to look at 4 different ones. Linear, quadratic, cubic, and 4th degree. The next type of function will be absolute value. The next one will be the square root and the cube root. And if we have 7, we're done. 1, 2, 3, 4, 5, 6, 7. That's good enough for now. Okay. So can anyone give us the simplest possible linear equation? F of x equals? That's it. This is the simplest possible linear equation. No one can find it an easier than this. So we do have to commit to memory the graph of this function. And here it is. It bisects, you'll see why this function is so important. It bisects the first and the third quadrants. It divides it into 2 equal parts. So can anyone give us or tell us whether this function is odd, even, or not symmetric? Very good. It is symmetric with respect to the origin. With respect to the origin, not with respect to the y-axis, but with respect to the origin. Perfect. The next one is quadratic. Can anyone give us the simplest possible quadratic equation that you can ever think of? That's it. That's the simplest quadratic equation. We graph this function. I'm sure you remember. And if you do remember, that will be great. And you'll tell me, when did we graph this function? When we looked at? Exactly. Thank you. Very good. Well done. So is this function odd, even, or none of the above? Very good. The next in line is the cube root. I'm sorry, cubic first. I don't want to jump. I want to finish polynomials first. Can anyone give us the simplest possible polynomial degree 3 cubic. That's it. And now you'll tell me, because you saw this function, I didn't tell you what it was. I kept it secret. But you will remember, I'm sure, when we looked at this function. Notice something very important. Right here at the origin, it does not look like this. So please pay attention. This is very slow. There is only one cross over there at the origin, but very slow, not fast like this one. So please graph it correctly. Very good. Odd, even, or none of the above. Very good. Symmetric with respect to the origin. Number 4 is the 4th degree. Can anyone give us a polynomial degree 4? That's the easiest one. There is nothing easier than that. And here's the graph. Very similar to the quadratic function, but notice something very important. It's very slow moving around the origin, like this one, not like this. So here it is. Slow. Okay, finally crossed. Slow going away from it, from the x-axis. This is not the same thing with this graph. This is quadratic. This is 4th degree. Slow. Odd, even, or none of the above. I will remind you of this in chapter 3. Very important concept. You will remember this. Odd, even, or none of the above. Okay, so let's look at the absolute value. We graphed a function a long time ago, which was the absolute value. Can anyone give us the simplest possible absolute value function? Perfect. So here's the graph of the absolute value of x. Can anyone tell us or remind us what type of graph is it? It's a V function. Awesome. Well done. Here it is. It bisects the first quadrant and it bisects the second quadrant. Odd, even, or none of the above? Of course. 2 more. 6 and 7. Square root and the cube root. We had a cube or square root today, a few minutes ago, but not the basic function. So the square root. Can anyone give us the simplest possible square root? That's it. Now, before we graph this function, and notice that I have not said that before. When we graph a function, what is the first thing we need to determine? Always. Correct. What is the domain of this? All real numbers. No. You're right. You're ahead of me, of course. So what is the domain of this? Right. I didn't say anything, right? What is the domain of this? Right. I can square any number you give me, right? What is the domain of this? You can look at the graph. Good. What is the domain of this? All real numbers, not the range. We're talking about the domain. In this function, I can plug in any x value I want. Okay. What about the domain of this? All real numbers. I can plug in the absolute value, anything I want. That's why I didn't even mention that. However, this is a different story. So I'm asking myself, what is the domain, or how do I determine the domain of a square root? What do I have to write? I have to write that the quantity under the square root must be, I'm in trouble if it's negative. I can't take the square of -4. So this, if the index is 2, like the square root, under the square root, what type of number do I have to have? Or Exactly. So in order to find the domain for this function, I have to write that this expression, which is the expression under the square root, must be greater than or equal to 0. If I have x plus 1, then x plus 1 has to be greater than or equal to 0. If I have 2x minus 3, then 2x minus 3 has to be greater than or equal to 0. And then I have to solve. Can anyone give us the domain of this then?
0 is positive.
Very good. So now we are ready to graph it. And keep in mind that this is the domain. It's not all real numbers. So here's the graph, and we have to commit it to memory. So this is the graph of the square of x. Odd, even, or none of the above?
None of the above.
Of course, not symmetric. Not symmetric. Last one is number 7, which is the cube root. So, can anyone give us the simplest possible cube root? That's it. Let's think for a moment and identify the domain. If I ask you find the cube root of 8, can you give me the number? That is the cube. 2. If I ask you find the cube root of 0, what will you say?
Yeah.
What if I ask you to find the cube root of negative 8? Correct. So what is the domain of any odd index?
All real numbers.
Correct. So for odd indices or odd index, domain, all real number. For even index, you can say I don't see it. Okay. By convention, we don't write it, but it's 2. Even index requires greater than or equal to 0 quantity under the square root. So, which is this? Domain. Okay, so let's graph this function and then talk about transformations. It's pretty similar to this, but it has domain all real numbers. So here it is. And this is the cube root of x. Odd, even, or none of the above. Symmetric with respect to the origin. Now, knowing all these graphs, we can finally talk about transformations. So there are 6 different transformations. Let's take a look. Shifts. They are vertical, horizontal. Reflections. 2 types. WRT with respect to the y-axis or with respect to the x-axis. Is this okay? So shifts, vertical, horizontal, reflections, WRT with respect to the y-axis or with respect to the x-axis. Last one has 2 names, stretching, shrinking. Slash shrinking. 2 types, vertical, and of course, very good. So then, here's the order that I would like to present them in. So we can start with vertical, horizontal. So this is what I would like to present. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Okay. Ready? For number 1. For number 1, I'm going to create two functions, f of x and g of x. So f of x is the absolute value of x minus 3, and g of x is the absolute value of x plus 4. They're not connected. We're going to talk about f first, and then we're going to talk about g. Which function from those 7 basic functions I used to create f? Which one?
Rational b function.
The absolute value.
Oh, right.
Yes, the absolute value indeed. So now let's take a look. We know the graph of the absolute value. Here it is. That's the base function. So base or basic function, the absolute value of x. What do you think this is telling us to do to the base function?
Lower it.
Right. So here's how I think about it. I'm asking myself, if I compare these two functions, what am I changing? Am I changing x? No. This has a plus 0. So obviously, I'm changing the other variable, which is y. So if I'm changing y, it's a vertical shift. And you will see if I'm changing x, it's a horizontal shift. So that's the reason why this graph moves down 3 units. So this has to be parallel to this 3 units lower, and parallel to that 3 units lower. So let's do that together. So 1, 2, 3. This point moves here. And now when we graph transformations or graph functions using transformations, I'm not really required to find exact ordered pairs. Transformations are something like this. I picture the graph right away, the absolute value down 3. But I'm not really interested where it crosses the x-axis and so on and so forth. If the problem is asking us that, in addition to use transformations to graph it, then it's a different story. Then I would have to determine the x and y-intercept, which the y-intercept is already there. So I just want to make sure that this is parallel, and this is parallel. And this is the graph of the absolute value of x minus 3. It used the base function of the absolute value, moving it 3 down. Down 3. Okay, what about this other function, which is g? What do you think? First of all, I have to ask myself, am I changing x or am I changing y? So I have to compare this to this. There is no change in x. There is only the change in y. So what do I have to graph? Yes, but not this function, right? The base function. So I'm going to move this function up 4. 1, 2, 3, 4. And I will graph, make sure that you graph it as parallel as possible to the graph of, so this will be the absolute value of x plus 4. And this is when we talk about vertical shifts. We change x, make yourself a, we change y. Change y variable, not x. So this is a change in y. Okay, so let's take a look at the second, number 2. So here's number 2. Let's say I want the absolute f of x to be the square root of x minus 1. And I want g of x to be the square root of x plus 3. Again, I'm going to ask myself what of those 7 basic functions was used to determine f and g. The square root. So the base function is the square root. I know how to graph the square root. I will do that right away. Here it is. And now I have to identify whether this is a change in x or a change in y. So look at the square root of x and look at the square root of x minus 1, and you will say, definitely this is a change in x. Because it's under the square root. It's not outside, right? So this is x, and that's x minus 1. Let's determine the domain of this function before we graph it, and before we decide, since it's a horizontal shift, which direction we go. So forget about all this for a moment. How do I find the domain of the square root of x minus 1? What do I have to write?
X is greater than or equal to 0.
What quantity we have under the square root? Can anyone read the quantity under the square root?
X minus 1.
Perfect. What type of number x minus 1 has to be so I can take the square root from that number? Or 0. So please dictate the inequality I have to write to find the domain of this function. What do I have to write? Anyone?
1, bracket 1.
The inequality first for everyone to see.
X minus 1 is greater than or equal to 0.
Awesome. This is what I have to write. So please keep this in mind. This is what we wrote before. And remember, I said this quantity has to be greater than or equal to 0. It can be anything. As long as it's under the square root, it must be that particular quantity, not x. That quantity must be positive or 0. So in this case, the quantity is x minus 1. Therefore, x minus 1 has to be greater than or equal to 0. And then x must be greater than or equal to 1. What is the domain of this function?
Bracket 1.
Now I'm going to ask you this question. When we change x into x minus a number, where do I shift the graph? To the? We just determined the domain. You cannot guess, right? We already determined the domain. So where does it go? To the right one. So the graph of the square root of x minus 1 starts right here and goes to the right one, the square root of x minus 1. That's why we determine the domain. So we remember this for good. Here it is. When I change x into x minus a number, the shift is to the right. Let's determine the domain of G now, please. What do I have to write and solve to determine the domain of G?
X plus 3 is greater than or equal to 0.
Perfect. Which means x greater than or equal to?
-3.
Very good. And the domain for, so let me write f here so it's clear. And the domain of G would be?
Bracket -3. Infinity.
Good. Now we know the domain of the function. So now let's come back to the graph and ask ourselves, when I change x into x plus a number, where will the graph go? To the left. According to the domain, it's very clear. So 1, 2, 3. So this is the square root of x plus 3. And that's the second. So if we change x into x plus 3, for example, we go left. If we change x into x minus 4, we go right. Left 3, right 4. And that's the second transformation. So now we go to number 3, which is reflection. Number 3 and number 4 together. Okay. Okay, so then I would like to graph f of x which is the square root of negative x And I will write a graph g of x, which is negative the square root of x. Again, I'm going to ask the same question: which function was used to create these two? What basic function did we use? Of course, the square root. Let's graph again the square root. We know now how it looks like. No questions there. So here's the square root of x. Agreed? And we know the domain. What is the domain of this function? Perfect. Always remember the quantity under the square root has to be greater than 0. Since it's plain x, must be 0. Okay. So now the next question is, do I change x or do I change y? Forget about g. We're not looking at g yet. So this is the square root of x, but this is the square root of negative x. If it's a change in x, something will happen. If it's a change in y, something else will happen. Is it a change in x? Yes. Perfect. So this was x. Where will negative x be?
Inverted.
Correct. Let's find the domain. Let's find the domain of this. I have no idea. Let's say we don't know. So please tell me how to find the domain of this function. What do I have to write? Perfect. And then? Very good. Awesome. So what is the domain of function f? Very good. So any interval notation. Perfect.
Bracket 0 or negative, parentheses negative infinity to 0 bracket.
Very good. So I know exactly where the graph is going. So here is the graph. So this is the graph of negative x. So what did we do? Remember, this is x, this is negative x. Perfect. Awesome. That's all I needed. So this function is a reflection of the square root of x, WRT, with respect to the y-axis. When we change x into negative x, reflection with respect to the y-axis. Very good. Let's come back to G now. Let's see what we change in this case. I have the square root of x. Do I have the square root of x there? Did I change x? No. So this is a function. The whole thing is a function of the y value. So what am I doing there? Exactly. I'm multiplying all y values by -1. Very good. So here's the graph of the opposite of the square root of x. All these positive values change to negative values. So this is a reflection of the square root of x, WRT, with respect to the x-axis. Perfect. So coming back, what notes do we want to put in the chart, in the table? So for number 3, the y-axis, what happens there? How do I get a reflection with respect to the y-axis? Yes. So I change x into? Awesome. I must change x into negative x in order to get a reflection with respect to the y-axis. Very good. Awesome. Number 4. When I want to get a reflection with respect to the x-axis, I change y into -y. So this is in short. Before we look at 5, I would like to give you an example that is a combination of several. Okay, let me